Hello everybody, I'm Fred Brechtel. I'm going to give you an introductory video today to our Model 9406 single channel Tri-color Absorption Photometer, or STAP for short. The primary measurement made by the STAP is aerosol light absorption, from which black carbon mass concentration can be derived. And the way it does that is by gathering particles onto a filter substrate, shining light through that filter substrate, and measuring with a very sensitive detector on the other side of the filter the attenuation of light. The attenuation can then be correlated to the absorption coefficient, the light absorption coefficient, and that can be converted to a black carbon mass concentration if you know the mass absorption efficiency of your absorbing aerosol as a function of wavelength. So the STAP is a very compact unit, and it is extremely sensitive. It has a sensitivity down to about 20 nanograms per cubic meter of black carbon concentration. That's extremely sensitive, sensitive enough to actually operate in the Arctic, and it has flown on UAVs in the Arctic. But it is so sensitive that it's very important to practice good electrical grounding tasks and practices whenever you're handling the STAP. Remember, these are UAV or other mobile platform deployable instruments, the STAP in particular, which means we've tried to keep the size, weight, and power use as small as possible so that you can fit the unit into the small space you have available. What that means, though, is that in some cases circuit boards, you can see the green main board right here, is exposed to anybody touching it. And if you have charge buildup and you touch the board, there's a chance that you may damage some of the electronics. That's especially important for the detector board, which is the board that's covered by this top metal cover. And you can see that we have here a ground strap tied from one corner of the board over to the main board that's tied into system ground that eventually needs to be tied back to your earth ground using this strap that's supplied with your unit. I mention that because the detector chip in here is sensitive to nanoamp magnitude currents. So if you discharge static directly onto this cover that's beyond roughly 2.5 to 3 kV, there's a chance you may damage it. So practice good grounding whenever you're changing the filter or when you're moving the STAP from one place to another. Make sure that you've got your ground strap on so that your static dissipated and you're not going to shock the unit when you touch it. Okay? So let me walk through the basic components of the STAP. This is the inlet. This is where the sample flow goes into the instrument. This is called a laminar flow element here, where we're measuring the true volumetric flow of the sample going into the actual instrument here. Okay, you can see we're measuring the volume flow by measuring the pressure drop from this point to this point using a very sensitive differential pressure sensor, which is the top pressure sensor closest to this thermistor connection. This thermistor is reading the temperature right on the outside of the LFE so we can correct for changes in air viscosity. So here you can see we have a tube labeled high side, and this is coming back through this splitter to the bottom port on the pressure sensor. So there's a good chance when you get your STAP that the LFE may be disconnected. So all you need to do is follow the labels. PS1 is pressure sensor 1, lower is the lower connector, the one closest to the board. So just push it right back on the barb. Be very gentle because they are plastic barbs, and then reconnect the black tube onto the top barb. You can see that we've actually split the flow here. There's no flow actually. We've split the pressure reading using this small metal splitter to a total pressure sensor. That is the second pressure sensor right here on the main board. The sample flow enters the body of the STAP right here. And you can see this stainless steel piece that's showing on the edge. That's actually holding the filter. The filters look something like this. They're small 10 millimeter paper filters. Okay? The flow goes up through the filter, leaving the particles behind on the filter paper. The flow comes out of the block and goes back into the block where it passes through you can see here, it comes out and goes back into the block where it passes through a second filter on the other side. There are two filters inside here. The second filter is used as what we call a reference filter. There are no particles on that filter, but the light that is generated down in this optical dome with LEDs, the light that shines through these filters gives us, by having a non-particle laden filter on this side, gives us a reference against which we can control the attenuated light in the sample filter. So the detectors are up here, the light is moving upwards through the filter, and the detectors are mounted on the detector board that are potted into this aluminum cover here. Okay? So the flow comes out after it passes through the reference filter, and it goes into this small tank, and the flow out of the tank is right here into the integrated pump, which is this blue piece. All right. So some of the other connectors that are worth mentioning here, you can see the pump connector going into the main board. The firmware that runs locally on the instrument automatically will control the flow in feedback between the LFE sample flow measurement and controlling the speed of the pump. So it automatically controls the flow rate to whatever you set it to. The flow rate should be set to anywhere between about 0.3 and about 1.5 liters per minute, maybe up to 2 liters per minute if you're in really low loading conditions. Some of the other things that I'd like to point out here, you can see this is the pump exhaust. We often put filters on the pump exhaust just to reduce the pump noise in the laboratory. In an ambient environment or a UAV, the noise is usually not a problem. And then over here, you can see a few different connectors. This is the 12-volt power input, this white 2-pin connector. And we would typically use a cable harness like this, which is supplied with your unit. You can see it comes with a barrel connector on it that will hook to the AC to DC converter that we also ship with the unit. You just need to click this in and make sure that the lock pin is going over the latch. You hear the click? So this is where we'll hook the 12-volt power. And then here you can see a couple other cables. This is the detector board cable right here. Okay, it's important to leave this connected down here. This is going up to the detector board here. You do not need to disconnect this cable when we do filter changes, which I'll show you in a minute. A couple of these other connectors, there's a USB connector here up on the top corner of the main board. This is used to connect a USB cable between the instrument and, if you purchase the Access Base Module tablet and the software, you'll actually connect the USB cable right from here to the hub supplied with the tablet. I'll show you what that looks like in a little while. You can see here a 3-pin connector that's used for RS-232 communication. If you want to communicate directly with the unit via RS-232, you can do that, or on your platform. You can hook into your onboard computer on the UAV or other mobile platform and then send commands remotely through your computer to the STAP via RS-232. And those are really the main connectors that are used. Finally, I'll mention this display. This display is one way to interface with the firmware of the STAP. You don't need to use the display to operate the unit. Once you have the settings and the default settings set the way you want, you can disconnect the ribbon cable here at the board. Don't just disconnect it here and leave the ribbon cable connected. You need to disconnect it at the board. You do that by pulling this blue latch lock on the connector out, and that lets you disconnect the ribbon cable. All right? Do not disconnect and reconnect the display while the unit is powered. You may damage things. All right? To reinsert the ribbon cable, always make sure that the black colored side of the ribbon cable is adjacent to the brown connector. You can see there's a brown edge of the connector on the ribbon cable connector. So you just stick this in so that it's all the way in and nice and square, and then you just need to push that brown connector in, and that holds the cable. Okay? So I'm going to just leave this connected for right now. If you have the Access Base module, you can use it to control the STAP and set your settings, and in that case you don't need the display hooked up. Alright, so that's the basic outline of the STAP. So the way the STAP works, like I mentioned, is we're loading one filter inside here with particles, and that means that it's accumulating particles with time. So as the filter gets blacker and blacker, less and less light will pass through the filter. More of it will get attenuated. And at some point, because of non-linear corrections that need to be applied for the loading effect of particles on the transmission of light, the data become more and more uncertain. So it's important, once you reach an attenuation level of about 0.7, that's monitored by the software, to stop the unit, turn off the power, and replace the filters. All right? Filter changes can take anywhere from 10 to about 20 minutes, depending on how good you are at it. But it's important for the quality of your data that you replace the filters. I generally recommend that you do this before each UAV flight, if you're doing flights, or any kind of other aircraft flight, or balloon ascent, or a particular field campaign day. So it's just good practice. And each time we replace the filters in the STAP, you go through what's called an initialization. That means that the firmware will check the optimum LED, the light settings, for the new filters. The filters are not necessarily all the same. Their transmission characteristics are different. And the system and software can automatically account for that by optimizing the light settings and other settings within the unit automatically. Those settings are stored in the firmware so that if you keep the same filters installed across multiple power on and off cycles, you can tell it, oh, just use the past filter initialization values instead of going through the initialization again. The initialization takes 5-10 minutes or so every time you install new filters. Whenever you install new filters for the best quality data, you need to go through a new initialization. Okay? Just so we're clear on that. So, let me go through quickly and show you what it takes to change the filters in the STAP. Now remember, I've got my grounding strap on, or at the very least, I've grounded myself to a table that I know is grounded before I start working on the STAP. All right, the power is off. There's no power connected here. The first thing I'm going to do is I'm going to loosen these two top screws in the middle here. Okay, these screws are never loosened. They hold the cover to the whole detector assembly. It's only these two screws that get loosened in order to remove the filters. Okay, so these screws don't need to be super duper tight. They just need to be nice and snug to pull down on top of the O-rings that create a seal inside here. All right, so now I'm just going to pull this straight up, and I'm just going to lay this to the side over here. Okay, so you can see the grounding strap limits you a little bit, but you can just pull it aside, and then you can see what we have is we have two filter holders, these stainless steel pieces right here. And these 4 bolts on each unit need to be removed, pulled out, and that will reveal the filter underneath. So let me see if I have the right size screwdriver here. Oh yeah, I do. Okay. So I'm just gonna loosen each one of these screws. I like to leave them in the stainless steel piece in the holes because they're quite small screws. So you need to be very careful not to lose them. Don't drop them into the instrument. All right. And so then what I do is I just pull this piece straight out. Okay, and I leave all the screws sitting in there. That makes it easier for me to keep from losing them. And you can see we have an O-ring on this side, and we have an O-ring on the other side, the 2 O-rings. That's how we get the seal. And this is the surface. Let me see if I can find you. Okay, this is the surface that is squeezing the filter, crushing the filter inside. Okay. Now you take the pair of tweezers that came with your unit, look in the ship kit, and you're going to pull the filter out. Okay. So I've just pulled the filter out with the tweezers, and if you wanted, you could put this in a clean Ziploc bag and you could extract this filter for chemical analysis if you felt like you could get enough signal off of it. Okay. In this case I don't, so I'm just going to put it down on the table. Although I do want to show you this particular filter. I don't know if you can tell, but there's a difference in the texture of the filter on one side versus the other. The rough side of the filter needs to face downwards. There are two types of filter papers that can be shipped with the STAP, and so you need to be very careful about which one you're using. One style, which is called a zoomy style filter, is symmetric. It's homogeneous. You can put it in any way you want, one way or the other. All right, and you can tell by looking at it, it's much thicker than the Paul style. This is a Paul style filter. All right, the zoomies you can put in one way or the other, it makes no difference. They're much thicker than the Pauls. The Paul filter, which is what I'm holding here, has texture on one side. That texture needs to face down when you put it in the unit. All right, it's very important because the unit will not work properly if you put the filters in incorrectly. Okay, so now I'm going to go to my bag of filters, and I'm going to grab just one filter like this. I'm going to make sure I only have one filter. Okay, I have one filter here, and I'm going to drop it right into the hole where it belongs. Okay, you can give it a little bit of push around the edges. Do not push it in the middle. You may break a hole through it. And then I'm going to go ahead and I'm going to push this right back down again. Okay? And I'm going to go ahead and use the Allen wrench to begin to thread the bolts in. Okay? I do this because I don't want the bolts to get pushed out and dropped in into the instrument. Okay? But I'm not going to tighten the bolts all the way. Guess why? I want to know which filter I've replaced. Okay, I have two filters I need to change. So I know I've just changed this one. I see the bolts are loose. These are all still tight on this second side here. Okay, let's see if I can move closer. Okay, I've changed this one. Now I need to change this one. All right, and I like to do them one at a time so that I don't have a lot of parts laying around that are going to get lost. Okay, so let me go ahead and I'm going to loosen this. Okay, loosen this guy. Loosen the third bowl. Loosen the fourth bowl. Okay, now I'm just going to pull this straight up. Okay, again, I've got all four bolts trapped in here. Do not lose these bolts. And now I'm going to use my tweezers to pull out the filter. Okay? I don't know if you can tell, but this is a very textured filter on one side, and that's the side that needs to go down. Okay? Put that filter aside. I don't want to use that filter again. Now I'm going to get a new filter. Only grab the filters on the very edge. Do not grab them in the middle. And check and make sure which one's the textured side. Oh yeah, that's definitely textured there. And that's going to go down. Okay, little push down. I like to put my filters back in the bag, back in the box, because I don't want them to get dirty. Close up the box. And now I can push this right back down again. Okay, voila. And now I tighten these bolts. You need to be a little bit patient. The hardware is very sensitive, and you want to get the bolts just nice and snug. Now I know I have both the filters in, and I'm going to tighten these bolts symmetrically. Oops, I tightened this one a little bit too much. and I noticed that the whole piece became crooked, and that's what you absolutely need to avoid. This piece needs to come down flat, otherwise it will not compress the filter properly, and you may get poor data because the filter is not being sealed around the entire edge. Okay, so I'm going symmetrically around the piece here. I'm going back from corner to corner across. Okay, corner to corner, corner to corner. All right, this one feels pretty good now. Got it nice and snug. So I'm not tightening it super tight, and I should always see a nice open gap here, a consistent gap across the entire edge here. Okay, it should not be closed on one corner and open on the other. That means you've not tightened it evenly. All right, so check that before you close up the unit. Okay, and now I'm going to move this back into place, tuck the ground strap back in, and this just has to get pushed straight down on top of the other block. Okay, these pieces go back in, the screws go back in. Tighten this loosely first, get these nice and snug. Okay, and we should be ready to sample. Filter's changed. Okay, so let me just check this gap over here. It looks pretty good. I'm looking at the gap here between the stainless steel piece and the aluminum. Looks pretty good. And what I'm going to do now is go ahead and plug in the power supply that would come with your unit. This is for lab use. You know, it's a standard kind of laptop power supply. It gives 12 volts out. I'm just going to plug this in here. Alrighty. And you'll see when the unit powers up, I'll explain to you what the display is telling me because it's difficult for me to show it in a way that you can read it. It tells me the firmware version. Right now we're shipping version 6.0. And it's telling me install a HEPA filter. Okay. If you want to do filter initialization, you need to have a filter on the inlet, because when we initialize and test for the optimum settings of the filter and the light, we don't want particles to be entering into the system. That will affect the results. All right, so you have to have a filter here. So the instructions say install HEPA filter, turn clockwise to confirm, counterclockwise to cancel. So for example, if I wanted to use the last initialization, I would just turn counterclockwise now on this black knob, because I'll just use the stored values. But in this case, I put in new filters. So I want to do an initialization, so I'll turn clockwise. All right, now it's going to go through a 10-minute warm-up, because it wants to be warmed up before it really does this optimization. If you know the unit is warm because you've been using it, and its electronics are nice and warm, then you can go ahead and skip. It says turn clockwise to skip. In this case, I'm going to go ahead and skip it just for the purposes of this video. Normally I would not skip it if the unit was cold and hadn't been run for that day, for example. So now I'm seeing the software is telling me it's adjusting LED power. 255 is the maximum power setting. So I'm watching the red, green, and blue LED settings change. The red LED is right at about 230, the green at 250. The blue was a little lower than the green. And now it's going through its initial readings phase. It set the LEDs. It found a good setting for the LED powers for each of the 3 LEDs. Remember, it's a Tri-color Absorption Photometer, 3 wavelengths, red, green, blue. All right? And now it's going to wait 2 minutes, and it's starting to take data now. And it's going to store those 2 minutes of data as the beginning of the averaging over time. All right, in order to establish the initial readings that are going to correspond to these new filters. Okay? So while this thing is initializing, let me show you how the STAP interacts with the user interface software that we've developed at BRECHTEL. So, in order to communicate with the STAP via our control software, all you need to do is you obviously purchase the 9400 base module, which will come with the software loaded and ready for you. And you'll also get a USB hub that comes with the unit. And you'll simply connect in the USB cable that comes with your STAP into the hub, and the other end will go into the onboard USB connector. And I don't know if you heard that, but there's a little dinging that shows the recognition of the hardware when it was plugged into the USB port. And what I can do now is I can look to see, if I go to the All tab, okay, first of all, let me show you, I'm going to go ahead and shut this down, and close it. Okay, so when you bring up the desktop, it's going to look like this, and you just double click on the UAV reader. We're shipping version 4.0 right now. And if I bring this window up over here, you can see, voila, it has automatically recognized the STAP. This one happens to be serial number 10. And it's telling me that the save feature is off right now. That means that data are not being saved to the tablet. I'm going to go ahead and turn that on. Just use the stylus. And then if I go to the STAP menu, you can see that it's live. You can see that these are all selectable items. And it's telling me that the initialization is done because under the filter section it's saying remove HEPA. Okay? That means it's finished. Alright, so let me go ahead and pull the HEPA filter off the sample inlet like that. And if I come here and select with the stylus and go to initialized, I can go to, oops, take readings. This, using the stylus upside down is okay. It's reinitializing now, actually, because I accidentally selected initialize. So, lesson there is don't use the software when you're looking upside down at a video screen. In any case, what's going to happen is once this countdown finishes, you can see it's counting down right here, it will begin plotting data. Hold on a second here. Now that the initialization phase has finished, you can see that the software is telling us the filter is initialized. And you can see now we're starting to read actual inverse megameter readings of the absorption coefficient, the light absorption coefficient, between about 3 and 4.2. It's red, green, and blue. If we come over here to the STAP Details tab, you can see all the detailed information that's available about the operation of the STAP. You can see here the LED power settings that were set during the initialization. You can see here the initialized filter readings. These were the readings that were determined during the initialization process. You can see here what the calibration values are for the flow, the laminar flow element, for the temperature, for the pressure, and for the voltage reading. We actually monitor the input 12-volt power so that you have feedback as to where your battery voltage is going and whether you might need to turn off certain instruments to save battery power. There's a section here that describes manufacturing info. There are diagnostics here that tell you about errors and pump power. There's also time and date that's on the STAP clock on board. And then there are settings and readings. Here's where you'll set the sample averaging time. We recommend 60-second average to reduce the noise in the data. Here's where you set the STAP flow rate. 1 liter per minute is typical. And then here it's reading the STAP temperature and the STAP pressure. So if you go back to the STAP tab, you can see that we're basically reading about 2.8 inverse megameters in the red here. We're reading about 3.7 inverse megameters in the green, and we're reading about 4.3 inverse megameters in the blue. So these data are being saved to file right now, because if I go to all, I can see that save file is on. And you can even see here a kind of a rough representation of the current readings. Now, if I had also multiple other instruments, for example, our UAV MCPC, or our OPC, or the chem sampler, each of these you can see are grayed out, and that's because those instruments are not currently connected. If we had them, we could connect them to the same USB hub that the STAP is using, and the software would automatically recognize them, and these displays would go live. And here you would see them recognized as different instruments, and you could select whether or not you wanted to save data locally to the tablet. Remember, you can always save data to all of the instruments via the SD card that's right on board on the STAP, for example. So that's pretty much your overview of the STAP. Again, if you have any questions while you get into more of the details, by all means, get in touch. Email is a good way. You can call us. We're always happy to help. Happy sampling.